Hello, everyone. Welcome to Cube Simplify. My name is Sayam Pathak, and also welcome to the Cloud Native Sustainability Week, Day 3. So, this is the last day because we don't have anything for the next 2 days. But over the period, what we have learned so far is on day one, we had co chair of TAG Sustainability, Leo, who explained us about the whole mission statement, the landscape, what the tag sustainability within CNCF ecosystem is all about. Why should you care? What are some of the stuff within the tag? What are some of the working groups like the comms and the green reviews working group, and how you can get involved? So if you haven't checked out and you want to get involved with the CNCF tag sustainability, make sure to check out the first stream. And in the second stream, which was yesterday, it was done by Kate from Fermion, where we talked about WebAssembly and sustainability. So how, first of all, serverless makes its, provide the benefits for the sustainability for green computing, and then how WebAssembly is a superb choice when it comes to serverless. And then moving on to very interesting topic, which is AI inferencing, and how WebAssembly is the go-to choice for AI inferencing, and that can help within the uh, cloud native sustainability ecosystem. And today, since we talk about CNCF and CNCF's first project was Kubernetes, so it always made sense to talk about some of the challenges within Kubernetes and how you can actually make Kubernetes as a system itself sustainable. What are some of the gotchas? What are some of the practices that can be used, and how we'll be able to make our Kubernetes clusters more sustainable? So that's what we'll be discussing all about today. And for that, I have Lukas, who is the co-founder and CEO at Loft Labs. Yes, I also work at Loft Labs, and I'm working as a principal developer advocate. And so excited. But it's not Lukas' first stream on Cube Simplify, like it's third or fourth stream on Cube Simplify. So he's not new face here. You have seen him if you have been following the channel over the years. Um, but so Lukas, please introduce yourself and a bit about yourself. Yeah, that would be good.
Yeah, good to be on your stream again, Siam. Now that we're co-workers, as you mentioned, right? This is the
Yes.
first one we do together since you joined the company, right?
Yes, exactly.
Yeah, I can remember, like, 3 years ago, or like even it's a bit over 3 years ago, I think was the
Over three
first
years.
vCluster stream, right? And you were the first one to actually do this live with us back then.
Yes.
Yeah, that was a lot of fun. Yeah, I'm very excited to be here to talk about sustainability. It's a really important topic, not just in the Kubernetes space, but definitely also a topic for us to take a look at as an industry and as a profession. Yeah, I'm Lukas, the CEO and one of the founders. At Loft Labs, we got the vCluster open source project started in 21. It's Apache 2 licensed project that essentially allows you to spin up Kubernetes clusters inside the namespace of another Kubernetes cluster. So you don't have to spin up as many clusters, right? And yeah, the project really took off over the past 3 years, thanks to a lot of people that got early excited, like Siam did, and kind of amplified the project and the project's voice in the community. And now a ton of companies are building their cloud infrastructure on top of virtual clusters and making the switch from spinning up hundreds or even thousands of real clusters, and instead go in with virtual clusters for greater efficiency as one of the main reasons. Very excited to be here, Siam.
Awesome. Let's get started. Let's try to understand first your perspective. What are your first thoughts when you think about Kubernetes and sustainability? Like, what are the first thoughts?
I mean, my first thought is, the reason why we started this company, right? It's, people are, I think in the early days, when you think back, right, like Kubernetes was designed as this large scale distributed system, right? And then, obviously the cloud providers made it really easy to spin up clusters. And it's interesting, it turned into, people spinning up more and more of these like 3-5 node clusters, a cluster here and a cluster there. You have so much cluster sprawl, right? And but it's not really what Kubernetes was designed for, right? Kubernetes was designed for being this large-scale distributed system, and then you have these small containers, and because of the way the scheduling works and the way that you can utilize these VMs, we can turn our virtual machines from pets into cattle, right? That was one of the big stories of Kubernetes and of the whole container wave that got kicked off, obviously, by the companies like Docker, etc. And then really Kubernetes operationalized these things. But again, because sharing a cluster is hard, and the cloud providers made it so easy to spin up a new cluster, right? And it seems to be like the path of lowest friction while still keeping things nicely isolated and separate. We end up with so many clusters, right, in a lot of organizations. And regarding the topic of sustainability, I'm not sure if that's super sustainable long term, right? If you're thinking about how much idle time you have in each one of these clusters, right? Thinking about when you spin up a cluster for pre-production development, right? Like nobody's using that at night, nobody's using that on the weekends, right? But it's running, and it's really interesting. We try to turn our machines from pets into cattle, and now we have the Kubernetes cluster as the pet. And it's even worse because the cluster is not just a single machine, it's 5 machines, right? So all we did was we put a layer of abstraction on the top, and then we have a now more complex and more expensive, right, and less sustainable pet to maintain, rather than actually having true cattle. And I think that's been a trend in the Kubernetes space in the past couple of years that I think is pretty concerning. And people are now aware and seeing it more and more as they're looking at it's not just like the economical environment that kind of has changed since 21, and there's been more emphasis on cost savings and greater efficiency, but it's also really, it pains people to see, hey, we're having all that data center capacity and all that electricity wasted, right, for idle compute, right? So people are interested in changing that, and that is a topic that obviously we saw, and our solution to that was starting vCluster as an alternative approach to having hundreds or thousands of clusters.
Yes, yeah, that's a very good point, because we have seen the adoption wave. So earlier, yes, the first step, the first problem within the ecosystem was the Kubernetes adoption itself. But now with the ease of, like you mentioned, the cloud providers making it easier to spin up the clusters, it has become very easy across cloud providers to spin up the Kubernetes clusters. Like you just click a button, enter a few fields or select them and just create the cluster. And it looks very simple. Yeah, like if your team needs a cluster,
it's a great thing, right? Like I'm not saying that's not a great thing. It's awesome. It really makes Kubernetes more accessible and widespread, but it also comes with the downsides.
Exactly. So the downsides, and we talked about that, like we cannot rely on the cloud provider to for every optimization. So they can provide you the Kubernetes cluster, but how to run those clusters and how to effectively use those clusters is in your hands. And also, Kubernetes is a very complex ecosystem, and it is meant to be used for production for very heavy workloads, and giving out all the cool stuff. But I see many places it is just being used for single applications, small applications, and which is basically you are wasting tons of resources. And if you use some of the toolings like Kepler, you will be exactly able to figure out how it maps. So you have your hardware layer, and obviously you cannot measure the capacitance and the frequency that tells you the carbon emissions from your Kubernetes clusters, because that's an abstraction layer above. But tools like Kepler, it has its own machine learning algorithm where it passes on the metrics, and then it gives you, okay, this is the carbon emission of your cluster. So think when you have multiple clusters, more will be the carbon emission. So when you have even less workloads running and you're wasting some nodes, which is the idle nodes, you are adding to the carbon emissions over there as well. So with that, Lucas, let's first try to understand, like, how do you define first multi-tenancy? Like, what exactly is multi-tenancy?
Yeah, I think multi-tenancy is really if you have in the Kubernetes space, right? If you have one cluster that can host multiple tenants, right? So you have one Kubernetes control plane, one set of nodes attached to this cluster, right? And the typical way to host multiple, and like very quickly, what is a tenant, right? So a tenant can be a team of engineers. It can be individual engineers. It can also be a customer environment, a deployment for a customer you're hosting. And maybe your current approach is to spin up a separate cluster for each customer. The multi-tenant way would be, I'm having one cluster for all customers in the same region, for example, right? And I think that way you can have, greater efficiency and consolidation into fewer clusters. I think that's one of the overarching goals of multi-tenancy, right? And a classical way to do this in Kubernetes to kind of segregate things in the same cluster is using namespaces, right? I think that is a built-in Kubernetes object. So obviously, a lot of people are familiar with namespaces. People use namespaces all the time. Even if they get started with Kubernetes, it's probably one of the first things you discover, right? You discover pods and services. Probably ingress and namespaces are one of the next objects you're discovering, right? Maybe deployments and stateful sets, right? There's a handful, maybe it's 10 resources that pretty much everybody knows after playing around with Kubernetes for a day or two. I would say namespaces is one of them. So people segregate by namespace, but the problem with these namespaces is often that there's resources in Kubernetes that are namespaced and other resources that are cluster-wide. And if you have a tenant, or let's say you have two tenants, right? Whether those are two different teams or two different applications you run for your customers, right? And they rely on cluster-wide objects, then it's a problem to keep them apart, right? By using a namespace, because the namespace can only put things, in isolation that run inside namespaces, right? It obviously can't isolate things that are not namespaced. And unfortunately, one of the key fundamental objects in Kubernetes, CRDs, right? Custom resource definitions, and a lot of custom resources that people are creating based on these definitions are cluster-wide resources. There are a whole bunch of other resources that are cluster-wide, but those tend to be the ones that are heavily used by a lot of operators and a lot of Helm charts, right? And then it becomes really an operational burden to say, how do we divvy things up by namespace, right? I think that is the challenge of multi-tenancy in Kubernetes when you're looking at how to make that work.
So basically, in Kubernetes, there is native concept called namespaces, and you have a lot of resources that are namespace bound. For example, resource limit ranges, policies, network policies, all those things. And you can manually kind of create all these things and try to create a separate tenant. And but when it comes to multiple tenants, then how would you do it in an autonomous way? That becomes a problem. How you manage it, how you give the access to that particular namespace only for your particular team, that becomes a challenge. And then security becomes a challenge. And then, like you said, the custom resource definition, the cluster wide resources become a challenge. How how those works within the namespaces. So there is a challenge, and to solve that challenge, there is this concept called multi-tenancy. So what are some of the existing tooling in this space? Like, how do you right now in 2024 create multi-tenancy? What are some of the different ways?
Yeah, I think there were quite a few approaches since we embarked on this multi-tenancy journey. I think one of the we actually launched a tool before we launched vCluster. That tool was called Kiosk. And I think there's another company in Italy. I think they launched a tool called Capsule. Both of these tools, what they did is they were essentially designed to automate a lot of the things you just described, right? They set up a namespace, they set up like, limit ranges, resource quotas, right? Network policies, right? It wasn't so much of a core innovation. It was more about like, how do you automate things? How do you do the necessary plumbing if you want to set up a multi-tenant cluster without having to do everything from scratch every time, reinvent the wheel, right? We are kind of like thinking that is the first thing. Let's standardize how these things work. And we quickly realized that automation only gets you so far. And the problem of this is, let's take a scenario, right? Like, let's say you do multi-tenancy with namespaces and you set up everything correctly. You're using one of these tools, right? And then you have a tenant that architects the application to run across 3 namespaces. Well, your network policy that just isolated everything to be in one namespace is now a problem because that tenant can create 3 namespaces, but the parts in these 3 namespaces are isolated from each other, as they should be in a multi-tenant cluster, right? Now you have the problem, well, for that tenant, we're going to add a whole bunch of exceptions to what we just set up, right? And then typically these teams that maintain the Kubernetes clusters, Kubernetes teams are typically more part of the platform team and part of like central IT, right? Versus the folks that architect applications and deploy things to Kubernetes, they're part of engineering. So the engineering teams are like, we want to make it work this way. We think this is the right approach, right? And then you have the platform team that's just like, well, the kind of multi-tenant cluster we set up doesn't work for this. And then the debate is like, should we give them a separate cluster? Or should we add these exceptions? But the problem is now we got to maintain these exceptions. And who wants to maintain exceptions to security policies over time? That sounds like a nightmare of responsibility, right? So yeah, I think that's part of the problem, especially if you're in a large organization. Think of a big bank or a big insurance company with like 10,000 engineers, right? Who's going to maintain all of these exceptions? Maybe if you're in a small startup like ours with like 50 people, we can manage these exceptions probably, but we're growing pretty quickly too. And maybe in 2 years from now, we'll be 200 people. And it already becomes challenging. But again, think of the Fortune 500s with 10,000 engineers, right? There's no way you want to embark on that journey. So multi-tenancy becomes really tricky. And then, we were exploring what other options are out there. And there were a couple of interesting projects that kind of originated at the same time as we started building vCluster. One of them was, for example, I think Alibaba got that project started initially. They called it Cluster API Nested and baked it into Cluster API to essentially do something like vCluster does, but much more on the cluster-wide level as a controller. And then there was an interesting approach. I think Red Hat got started in Magi. I think what they are doing is essentially saying we host a control plane in a pod, and then you attach nodes to it, and then you basically have a separate cluster that technically runs in a separate, that has a separate control plane, but you don't necessarily you reuse the same nodes, right? You attach separate nodes to these clusters. The way we approached it with vCluster was a little different, and I think we took it to the furthest of the extremes. We essentially said, like, we want a separate control plane, but we still want to share the nodes. And that's a very big difference, right? Because when you have different nodes for each one of your virtual clusters, right, then yes, you're saving maybe a little bit of like the control plane fee, etc. But you also have the problem, like, if you have these nodes underutilized, right, you still have a similar problem as if you had separate clusters, right? So there is a little bit of efficiency gain, but there's no max efficiency gain. And with vCluster, we take a little bit of different stance. We're essentially saying we'll do the max efficiency gain. We share all the nodes. The vCluster has no separate nodes. And only if you specifically need that, you can attach nodes to the vCluster, right? So let's say you have specific security restrictions, right? Or you're saying, there's a specific GPU node, right, that should only be dedicated to this virtual cluster, right? You can do that. but there should be a set of like nodes or node pools, right? You can still separate things. You can say this business unit and this business unit should be completely separate, so I'm putting them in different node pools, right? But you're utilizing the same infrastructure as the underlying, we call it host cluster, right? That essentially is the traditional Kubernetes cluster, your EKS or your GKE cluster or your private cloud OpenShift cluster, right? Then you spin up these vClusters in the different namespaces, and now you hand out these vClusters instead of handing out the namespaces directly. But when you're launching workloads and you create CODs, you have a full-blown cluster, full autonomy inside that vCluster while connecting to this vCluster control plane. You feel like you got the whole thing. But in the end, all of your pods end up in one namespace, just as if I just gave you one namespace in the first place, right? So you kind of get around maintaining any exceptions and having to create separate clusters for everything. But at the same time, you pretty much make Kubernetes namespace-based multi-tenancy work out of the box by just adding a very slim container that runs this vCluster. That is the whole idea, and I think that resonated really well with people because it was really like a true innovation, and it wasn't easy to get there. And you asked about what other tools are out there. One of the inspirations and credit goes to them. I think there was the K3V project, right? Which was Darren Shepard, the founder and CTO, co-founder and CTO at Rancher. He built this project where he said, like, can't we put like Kubernetes or K3S specifically in a pod? And that kind of, I think, got the whole idea started. I'm not sure if the other projects that are out there were inspired by that as well, but we definitely saw that. And that's also why we started initially with K3S as the main distribution for vCluster. Over time, we now actually made vanilla Kubernetes the default and recommend for people to use that. But that's another tool that definitely kind of was an influential piece on the path to get to Kubernetes multi-tenancy where we are today.
Awesome. So yeah, I think those are some really good points. So there is need for multi-tenancy to use the resources efficiently. And then there is this concept of multi-tenancy. And multi-tenancy is hard, and people have been trying out with different approaches and different tools. Like some people call multi-cluster as like a bit of control plane, and then different nodes try to save some cost and some nodes over there. But this is actually the slicing of the Kubernetes cluster. Just as you create a virtual machine in the cloud provider and you get that virtual machine which is running on the piece of hardware, you get a slice of that, and you still are the owner of that. You get that you are able to install anything, you are able to work on it with anything. So similar to that, with vCluster, you are able to get that slice of the Kubernetes cluster, and you are able to use that slice. But when you get that kubeconfig file, you will be able to see that you are able to run workloads, you are able to create whatever it is, you are able to create namespaces, you are able to install stuff, and that is your Kubernetes cluster. For you, it's no different than a regular CNCF certified Kubernetes distribution. So you are able to use that. But for the admin, these are the pods which are running on the host cluster. So it gives you that. Although, yeah, there are some external features, like you can attach external etcd, and you can have external data store if you want more high availability for enterprises as well. But yeah, I think that multi-tenancy is very interesting, like doing it this way, and that's why it has picked up a lot, and that's why there are hardly anyone out there who is doing in a similar kind of way. Yeah, there might be new projects popping up here and there, but this one has seen the problem, trying to fix it from the level 0, and now having a lot more features and capabilities for the enterprises as well.
100%. Yeah, I think part of it is the interesting thing about vCluster is it's so easy to spin up and deploy, right? All you need is a namespace in a cluster. Maybe you're already running in a multi-tenant cluster, and your IT team gave you access to a namespace, and that namespace is too limiting for you. All you need is the permission to create a stateful set for deployment, in that Kubernetes cluster and a service, and you can launch a vCluster. So you can literally run helm install, deploy that vCluster, do port forwarding with kubectl port forward command to that vCluster service, right? And then you have a kube config that gives you a full-blown cluster. So you elevated your privileges without telling anybody. And you kind of got your own cluster now, right? It's a virtual one, right? But it's kind of like it's a very interesting approach, and I think that simplicity of getting started is the reason why vCluster has become so popular so quickly. But then again, you can go beyond and you can say, hey, we attach separate nodes. Here's how we change the syncing behavior, right? Like, I think it's very enterprise grade to customize it. And when teams, discover that there's a lot of vClusters already spun up in their multi-tenant clusters, sometimes the central IT Kubernetes admin teams, right? They want to, customize things, make things easier, make that offering available, not just for the user who found out they can do it, but as a general offering to folks, and see it as an alternative to spinning up real clusters. And that's when it becomes like really enterprise grade. But it can start very lightweight. It can start with, hey, I'm having my Docker desktop locally, and I kind of wish I could create multiple clusters with it, but I can't. There's one cluster in Docker desktop, and now you can just spin up vClusters in the namespaces of it, and it feels like we have separate clusters in that Docker desktop, although it's just a one-node little, Docker desktop Kubernetes cluster. I think it can start as lightweight as that to get you that slice. And I think one thing you pointed out is really important too is we are certified Kubernetes distro with vCluster. We're the only certified distro for virtual clusters. And that's very important because, as you mentioned, when you get a VM in EC2, right, Amazon's cloud, you expect that VM kind of to be the same like a real physical machine. VMs wouldn't be so popular if there was a whole like bunch of asterisks attached to like, hey, you can't do this and that, right? But no, when people need a server today, they're most likely just going to get an EC2 instance or some kind of virtual machine, right? And they don't even notice that it's not like a full-blown bare metal server, right? And that's great. We're trying to achieve the exact same thing. So if you hand out a vCluster, it should feel like a real traditional Kubernetes cluster, and you shouldn't even notice that this is a virtual cluster. I mean, there's always these edge cases, right? There's always the 3% of cases, right, where the VM is not good enough, and you need really access to the physical hardware drivers, etc. Same thing applies to a vCluster. There's these edge cases where teams need to go so deep on the node level of something, right? Then of course, right, vCluster may not be the right solution for you. But for 90% plus of the use cases out there, you're probably talking about deploying a couple of like custom resources, deployment services, ingresses, right? And then vCluster can be a really great solution to get you that full-blown cluster without giving everybody a full-blown cluster and then wasting a lot of resources and having it super underutilized, right? Just because it was the more secure and more easy way to spin it up, right? That's essentially something where we're saying, no, you shouldn't just do it because this was like the other solutions seemed hard, right? That's what we're trying to do. We try to make the other solution viable and easy enough with vCluster. So you say, hey, it's worth doing this, right? And then, it just becomes the more efficient way to do that.
Awesome. So let's say there is an existing enterprise who wants to kind of implement a sustainable Kubernetes strategy. So what would be your advice to them?
I think it's a multi-layered approach, right? It starts with looking at what is my utilization in Kubernetes today. If you look at and a lot of people, to be clear, they are highly underestimating waste. So when you ask people, how idle does your Kubernetes cluster run? Like, pick any cluster in your infrastructure, point at it, and tell me how much time percentage-wise, is this cluster actually fully utilized, right? Like, or what's the percentage of it being utilized, right? People are so off. most of the time because they lack the instrumentation, right? So the first thing we tell them is, okay, look at look at your nodes, right? Look at how bin packed your nodes are, for example. And there's solutions for solving that problem, right? There's Carpenter, for example. That is a great solution in AWS, and I think they made it work in Azure as well at this point, where you can say, hey, we're provisioning more right-sized virtual machines for the particular workloads, and we do bin packing of our workloads to essentially optimize the nodes, right? That is one layer of the problem that you can attack, right? Then you look at the next problem of like, okay, all of this depends on like, did we specify the right kind of like sizing for our, containers, right? That's where limits come in. There's great tools out there. I think, there's the kubectl and the CAS and like a lot of other tools that address that problem that tell you essentially, okay, what should be the requested and the limit of CPU and memory and other resources on the particular containers, because that's a really hard question. You ask any engineer, great that you wrote this code. Now we have a binary. If you want to run this in the pod, how much CPU does it need? Almost never you get an answer, right? And if you get an answer, it's often just a guesstimate, right? It's often completely off, right? So, and then you layer in a tool like Carpenter, which technically can solve some of that pain of node utilization, but it's working, maybe not of ideal data, right? And I think you can hook up instrumentation like metrics server, right? To say, hey, let's hook it up based on the real usage, which is obviously much, much better. And then you have tools like, again, like, CAST, etc., that say, we're going to adjust our Kubernetes definitions to match what the actual needs are, right? And it may fluctuate depending on the usage of the. That's definitely one area. Right sizing of containers, right sizing of nodes, right? That's two really, really big topics. That whole right sizing topic, right? I think these two aspects, I would say that is definitely something to look at. And then you have the problem of, okay, we right sized our workloads and our nodes. How do we right size, the cluster itself, and who gets a separate cluster and who has to share a cluster, right? And that's an aspect where vCluster can really help, right? Where you say, okay, how many of these clusters do we have out there? And maybe our applications are right sized, but nobody's really using that application right now, right? I think that's an interesting thing, because let's say you have 100 engineering teams and they run in 100 clusters, and you have all these right sizing tools and you have Carpenter in place, and that's great. They all run super efficiently, but these 100 engineering teams are probably not working on a Sunday or at night, right? So who spins all of this down, right? And I know there's some more trivial approaches to kind of spinning things down, and some like very sophisticated approaches to spin things down, right? I think there's different Kubernetes tools. Like I think kubegreen is one of them, right? For example, where you can spin things up and down, right? In vCluster, we have a built-in solution. We call it sleep mode, right? So if your application runs in a vCluster, in a multi-tenant cluster, obviously that's already more efficient than having 100 separate clusters. But who spins it up and down? Well, maybe kubegreen can spin your applications up and down. vCluster can spin your applications plus the vCluster up and down, depending on the ingress traffic, depending on the kubectl commands that hit that virtual cluster, right? I think that's a set of problems that is very, complementary to the right sizing topic, right? It's essentially, how do we get the most out of the architecture, right? The fewest amount of clusters, the fewest amount of nodes, and let's turn things off when they're not being used. And it's really hard to shut off a Kubernetes cluster. Like, it's an interesting question when you ask an IT team, of these 100 clusters that you're running, which one of them is right now currently in use? Really hard, right? Really hard to do that. And then if they would be able to say these 4 are not used in the past 30 minutes, and you'd ask them, can you dynamically spin these entire clusters down and spin them up again as soon as ingress traffic comes in? It's a really tough problem, right? In vCluster, we do it automatically. call it sleep mode. It's something that we actually encourage people to, when admins set up the product and roll out virtual clusters to their teams, we encourage them to enable it by default. So by default, virtual clusters go off, and only the ones and the workloads and the clusters that you label as, hey, this should run continuously, they keep continuously running, right? Because in my opinion, especially in pre-production, if you don't make it the default, it's really hard to enforce this stuff later on, right? It's much easier to say, hey, from the start, this should go to sleep without any extra headache and configuration. I think that's another big part. And then there's more things to optimize, of course, right? There's things like the networking and like, the traffic in your networking, right? Like all of these aspects as well. But I think it's a good point to start with right sizing and with reducing idle capacity and with consolidating things into fewer clusters, right? That's the three things I would say are going to get you, the quickest to a more sustainable, more efficiently run Kubernetes cluster.
And a lot more cost-effective solution as well.
100%. Yeah, it kind of goes hand in hand, right? Because if you're paying for it, someone else is running it, and someone else is wasting compute resources, right? That means energy. It also means hardware, right? I mean, as much as I love all the developments that come out of the AI kind of world, right? I'm very concerned about that, footprint, right? When I hear these energy numbers going up, and when I hear the number of GPUs being produced and deployed for this, and I'm like, that feels very much like, again, like what we did with Kubernetes, right? With like, let's just spin up all of this and like we'll optimize later. But I think especially in that AI world, that optimization will have to come pretty soon because that growth is so exponential in that space.
Yeah, exactly. So very interesting points you brought up. Just to recap a bit. So for an enterprise who is running, let's say 100 plus clusters right now, their strategy, and they have done it because like we mentioned earlier, with cloud, the adoption has become easy for Kubernetes with the managed Kubernetes service providers. They want you to actually create more and more clusters because it's a business for them. So they get money. More number of nodes you spin up, the more money they get. The more number of clusters you spin up, the more control plane fee they will be able to charge. The more nodes you spin up, again, more cost they earn, more revenue they earn. So this is what is easy part. Like they'll give you, okay, take this, spin it up. But now it's up to you to optimize that. And there are a lot of optimizations that Lukas just mentioned, like right sizing of the resources, right, when you are doing with the containers, and some of the toolings that can help you out, right sizing of the nodes, using very, proficient cluster autoscalers like Carpenter. There is Kubernetes cluster autoscaler as well, but Carpenter is much more, efficient in this way. So it helps you even more. And then very interestingly, the Cost AI has their own intelligent autoscaler, which is, even more efficient. So depending on what tooling you will be using, you will be able to, optimize this. And then the concept of multi-tenancy comes in, like reduce the number of clusters so that you can just reduce the number of nodes that you are spinning up, reduce the number of idle time, wastage of resources that you're using up, reduce the number of control plane that you're using. It will not only not only reduce the amount of resources contributing to sustainable computing, but also it will be reducing your Kubernetes costs, which will, be going in millions very soon when you have 100 plus clusters running for different teams. And very interesting topic that Lukas brought is about the Kube Green project. Just to let you know, Cube Green is actually part of the cloud native sustainability landscape, and it's one of the project listed over there. What it does is it helps you scale down your deployments to zero. So you have a specification file where you mention that I want to scale down the deployments, and you can have the exclusions, like these are the deployments that I want to exclude, and then you give a timing. So sleep at and wake up. So you give these parameters over there, that what time, let's say 11 p.m. to 5 a.m., something like that. So you tell, and then it automatically wakes up. But it doesn't know, like you have to specify that, like this is the file that you need to mention. So it's not automatic, it's not out of the box. So you need to specify the file. So what Lucas just mentioned is that there is a thing called sleep mode, which is very interesting, in vCluster, that automatically detects, and for the workloads and the cluster. So kubegreen doesn't work for Kubernetes clusters. Kubegreen only works for the deployments and jobs as of now. No other Kubernetes resource, only the deployments and the jobs. But the sleep mode within vCluster can help you both in the workload and also the virtual cluster itself, and that too automatically. So you can definitely mention that these are the resources, please do not touch it, and let it keep running. And then for the others, it automatically detects the ingress traffics and all the traffic that is coming from different sources, and then it shuts it down. I think that is a more interesting way, the serverless way, especially for the dev test stage. These environments very safe to implement over there. Definitely for production, if you want to use it, it needs a bit more, there is a term in chaos engineering which is called the blast radius. So you have to make sure you are aware of the blast radius when you are doing things in production. Even chaos engineering is meant to do in production, but you have to be aware of the blast radius. You cannot just blow away anything in production. So if you want to use these things, any of these things in production, it requires a little bit of tweaking over there. But yeah, since you mentioned kubernetes, very important point, you covered one particular project in the cloud native sustainability landscape as well. So yeah, vCluster
I mean, you
is
mentioned, right? You mentioned production versus pre-production, right? Like kubegreen and the sleep mode that we're working on, I think is much more targeted for pre-production versus when you look at KDA, for example, right? Like people always get confused. There's so many autoscalers, as you mentioned, right? There's cluster autoscaling, then there's like, autoscaling of the applications. Now we have autoscaling of virtual clusters somewhere in the middle, right? Because a virtual cluster kind of is an application, but it's also a little different, right? It's very interesting. But like the way I look at it is the least amount of configuration is better for pre-production, right? Because in production, when you like take a look at KDA, right? KDA are very complicated to autoscale any of your workloads, right? It's not a cluster autoscaler, right? Like use Carpenter or any of these tools for that. They're always going to be complicated because they scale nodes, right? There's always a certain complexity on that end. But when you take a look at something like KDA, that's amazing for production, right? There's even more sophisticated proprietary things, right? Think of like commerce companies like e-commerce, right? Where you have like Black Friday or Christmas shopping or something like that, right? Where like there's huge spikes in traffic at a certain time within a couple of hours. Think of trading applications where Monday morning at like 8 a.m. or 9 a.m. or whenever the stock markets open in a particular country, there's a huge spike of trades coming in from the week, right? Like there's these kind of scenarios that are highly sophisticated in production that's exactly what companies should be focused on. But in pre-production, when an engineer wants to add a new microservice, it's not the first thing they think about. To say, how would this auto scale, right? Like they don't even know how many resources this would consume, right? They may not even have any instrumentation in place. So my mantra in that end is like keep it as simple as possible, right? You mentioned kubegreen, like it's great if you put a schedule, for example, in place where you say, hey, here, this is the hours where it runs. With vCluster, we make it even simpler because we detect all of these things because we're kind of you're managing your entire cluster and your workloads, which puts us in a very unique position, right? And turning off the workloads and turning off the cluster, if you have an underlying cluster that auto scales, right, makes it really easy to shut off an entire vCluster and have the benefit of the overall architecture getting reduced when 5 vClusters are gone. Maybe Carpenter can kick off 2 nodes, right? That's exactly great. But our config is really easy. In vCluster, you just give us a timeout. You basically say if there was no activity after 5 minutes, so literally that's the config option that you need. It's one field that tells us the number of like minutes or 30 minutes or an hour or whatever it is, right? And then we do the detection. There's a lot more options if you want to fine tune it, but that's as easy as it gets for an engineer to say this should go to sleep. And if you're a company and you're rolling out vCluster more as a central tool, right, our platform can actually automatically enforce this setting to be on all vClusters. So you can say, hey, that needs to be specified, and if not, it's going to be 30 minutes. Right? And I think that is something that's that makes that pre-production work a lot easier, because you just don't have to think about it, right? Whatever experiment we're running and what you're testing out, you can be sure that you're not wasting a ton of resources with it, but you also don't have to figure out before you deploy anything what CPU and memory requirements has you set it up, because again, that feels like magic to most engineers.
Awesome. Yeah, so moving on. So we have, like you talked about the sustainable strategy. Now, if a company is adopting this specific sustainable strategy using vCluster, are there any trade-offs with the performance when it comes to vCluster? Because like with respect to the number of API calls to the control plane, because in the end it's the pod, and in one cluster, how do you say, like, how many virtual clusters can you create, in one particular uh, host cluster, and what are some of the challenges and performance hits over there?
Yeah, I think it's interesting. Whenever there is a virtualization technology that arises, right, there is the question of, is there performance hit? Because it feels like we add a layer, there must be complexity, there must be a trade-off, there must be a performance hit. I think, look, virtual machines probably have a little bit of performance hit compared to bare metal. And there are certain applications which need that final edge of performance, right? Like maybe high frequency trading needs that. Like, I'm not an expert in that field, but like I could assume like those kind of applications, every millisecond matters, right? But or nanosecond probably. But the reality is, for the vast majority of applications, spinning something up on bare metal versus a VM, it's not going to make a difference. And spinning up something in a container versus spinning it up on a VM directly, it's not going to make a difference. And spinning it up in a vCluster or a real cluster that runs on VMs and uses containers on the bare metal hardware is not going to make any difference. In reality, the interesting piece, the way we architected, so, it's easy to say that argument, right? It's even better if you can prove that there's actually no difference. So when we designed vCluster, the way it works under the hood is when you run kubectl create, right? And you create a deployment, right? Let's say your deployment YAML file, right? You run kubectl create deployment YAML, right? That call goes to the virtual clusters API server and adds a deployment object in your cluster's data store. Then your controller manager sees, oh, the replica number is 2 in that deployment. So I create 2 pods. That's just another entry in your data store. So far, this is exactly the same process, the same thing your EKS cluster does. Nothing has changed. There's no difference in performance. It's regular Kubernetes that we're running, just like EKS is running. Regular Kubernetes, exactly the same code, right? So you get 2 pods. And now is the interesting piece. To launch these pods, you need to have a scheduler that knows all your nodes, puts the pods on the right node, and then the kubelet on that node can spin up the containers, right? And that's why the virtual cluster is different, right? What happens here is we have a so-called syncer instead of a scheduler. And what that syncer does, it copies these 2 pods to the underlying namespace. So it talks to the Kubernetes API of the underlying, let's say, an EKS cluster, right? And now I have 2 pods. And then that scheduler of that cluster is going to schedule them, right? And obviously you can have things like, pains and tolerations and putting it on specific node pools, right? And affinity and anti-affinity and all of these rules that affect nodes, right? Which is great because it's your regular underlying cluster. You can also have OPA that says like, oh, privileged pod, nope, not allowed, right, in my EKS cluster. But you have that one extra hop of, the syncer, instead of the regular scheduler getting it directly, the syncer getting it and copying it down, and then the regular scheduler is getting it. But that extra step only happens once, and that is when that pod gets created. Once the pod is down there in that EKS cluster, and that scheduler picks it up and launches, that's exactly the regular Kubernetes process. And once that application runs, it gets run by the same node and by the same kubelet, right? Nothing is different as if you were to create that pod directly in that namespace, right? That means there's zero performance hit. And because of that architecture, right, I think everybody who is listening to this and every customer we've ever signed on and we explained how this works under the hood, right, pretty much immediately sees whether I run kubectl apply pod YAML on the namespace or the vCluster does that for me, right? As soon as that pod is running, it's the same pod, right? And I think that's how we can confidently say, you know, maybe the creation of the pod takes a millisecond longer, but the performance of the pod, there's no difference. There's no difference in terms of networking and compute because it is run exactly like any other pod in that Kubernetes cluster. And I think that's the beauty of that architecture.
So basically, the standard Kubernetes limits that would be there for the host cluster still stands for whatever number of virtual clusters that you spin up. And all the hit is being taken for each virtual cluster is by its own control plane and its own data store. And then the syncer just copies it, and then it's a regular Kubernetes process that just there for creation and deletion of the resources, which is there.
100%. And because of that architecture, you may notice that a lot of operations in the Kubernetes cluster are about things that have nothing to do with containers, right? A deployment. It's just like, how do we create that pod, right? And then you have CRDs who then create deployments, right? And like these kind of like there's so many virtual layers already, right? That are just business logic. They have nothing to do with the underlying actual hardware directly, right? But it's still a lot of API calls, and it's still a lot of watchers in these clusters. So one of the challenges you have with big clusters is that the control plane is under a lot of load from all of these requests. And one of the beautiful things about vCluster is actually it takes a lot of load off because that load is now on the vCluster, and the underlying cluster, the only real essential operation it has to focus on is pods, right? And I think that actually makes Kubernetes clusters a lot more scalable, right? Which is what Kubernetes was designed for. So we're actually helping to shard Kubernetes API servers a little bit. And you were talking about chaos engineering and the blast radius. Think of a faulty controller running in a Kubernetes cluster, accidentally creating thousands of secrets, right? That can bring your Kubernetes cluster down. In a vCluster, it brings your vCluster down, right? And the underlying large cluster with so many other tenants keeps running, right? You can upgrade a vCluster, and the underlying cluster is still going to keep running your pods, right? You can have different versions of Kubernetes in different vClusters, right? And that is not a problem. Like, let's say you want to upgrade a multi-tenant clusters, you have to tell all your tenants, hey, we're upgrading to this version. Are you ready for this? There's going to be a lot of questions on like whether everybody's ready at the same time or not, and these ones want to stay behind. These ones want to already move to the newest version, and you're not even planning to go there. In a vCluster, everybody can run their own version, and the underlying cluster has a version. And as long as they agree on what is a pod, we're good, right? And I think that's the beauty of how we designed vCluster, and I think why it's so popular.
Awesome. Yeah, I think we have covered almost all the stuff. And I hope people who are watching and people who will be watching later, you get a gist of how to optimize your Kubernetes, like different ways to optimize your existing Kubernetes clusters without introducing any massive changes, just using some of the tools in the most easiest way possible to turn your existing Kubernetes cluster in a way that it becomes more efficient, and you are able to use your resources more efficiently, and you are able to contribute to the sustainable and make it more sustainable as well, and save costs as well, and use the less control planes, make it easy to manage, and also reduce the reduce the impact or reduce the overload on the API server with vCluster. And I think that's one of the beauty of this project. It's open source, Apache 2. You can try it out and try using that for your existing Kubernetes clusters. And for the enterprises, we definitely have a pro version with a lot more pro kind of features that you can use. Yeah, thank you, Lucas, for joining in, hopping in for this call, explaining about all your expertise in this area for the over the years. And for the audience, if you have any questions, please feel free to drop them in the chat, or even you can join the Slack, or you can put that in the comments later on, and we'll be happy to answer that. By the way, we'll be there at KubeCon North America. We have a booth. We have a few talks at the Platform Engineering Day, and at the main KubeCon as well. So if you are attending KubeCon North America, we will definitely be there. We have a booth where we'll be happy to talk about in deep dive about this and show you the demos. Like we didn't do any demo. This was a discussion. We wanted to understand. But if you want a hands-on demo, then feel free to reach us out, and we'll be happy to do a demo as well. And you can check out our Loft YouTube channel as well, where we keep on uploading some of the efficient demos and how stuff works under the hood, that are there. So you can check that out as well. So yeah, thank you, Lucas, for joining in and explaining about sustainability for Kubernetes and how multi-tenancy helps it in a big way, and how vCluster then helps it, apart from all the existing tooling out there. Anything additional you want to add?
No, my pleasure, Sayam. Thank you so much for raising awareness for that topic, and that goes out to the whole tech sustainability. Of course, I think it is an important topic that I think has been taking a back seat since Kubernetes became so popular, and I think it is a topic. We've seen all the natural disasters pick up, and we've seen all the researchers tell us, right, it's ocean temperatures rising, etc., because of all the energy consumption that is not as sustainable, unfortunately, as we would like it to be, right? I mean, we'd love to have carbon emission zero electricity everywhere in the world, right? But we're not there. So it is, I think, important to work on how can we optimize these things on a smaller individual scale, as a company, as an individual yourself, right? And then obviously the broader kind of world, kind of working on producing more carbon emission free electricity, but also jet fuel, right? There's so many topics that are much bigger scale than us as individuals, but obviously we and the companies we work for can make a contribution on that path as well. And I think it is a really important topic to surface. So thank you for doing this, and thanks to the tech sustainability for pushing these topics along as well.
Yeah, exactly. All the stuff that you mentioned is pretty important. That's why the Sustainability Week is happening all around the globe. So make sure you check out the website of Tag Sustainability Week. Make sure you check out all the events happening. Maybe some of the events are happening very close to you. So make sure to attend that. This is a full week. Actually, some of them are doing later as well, at later October stage. But yeah, this week, probably you'll find a lot of events all across the globe. So make sure to check that out. And if you are nearby somewhere, then please do attend that. It's pretty important topic. And you as engineers for writing software can actually do a lot, keeping the political agenda, all those things aside. So yeah. All right. Thank you so much, everyone, for joining in. And thank you again, Lucas. This is the end of the Sustainability Stream series, and we'll see you next year. Bye.